Hey guys, everything new under the sun. It is time for my, I guess my final review, maybe my final review of my big deep cycle batteries. Let me flip this one around so we can see the front of it. So this is my Nautilus Pure Lead RV Marine deep cycle battery, 90 amp hours, the Ultra XD, 99.99% pure lead absorbed glass mat AGM. Now I've had this for 2 years, 7 months, I believe. I'm going to put the image from the little app on my iPad that I was using to basically see how old it was and count its age basically. And this one I paid, I think, $350 for it from Canadian Tire, brand spanking new. I got the AGM because we put it in our camper for camping because it doesn't release gases, so you don't want gases being released in your camper, obviously. So I got this, $350, about 2 years, 7 months ago, coming up on 3 years. We'll round it to 3 years to give it the benefit of the doubt. I have my other Nautilus deep cycle battery, which is a plain old lead acid, flooded lead acid battery. It is just over 3 years old. Now, I say that because I've got a problem. These guys aren't getting 100% charge now. And they're both about 3 years. Now, you'd expect to get, you know, a good 4 years out of your batteries. Now, these have been sitting pretty well charged. I think I've never really... They've maybe been drained down to zero a couple of times, but not too many times. And I made sure I had solar panels on them most of the time, trickle charging at minimum to keep them topped up. But this guy here, I noticed it because in the shed, in the chicken shed, I noticed that I'd look at the voltage. It would be 12.7 at night, and then I'd turn the lights on, and after maybe 15 minutes of the lights being on, they'd be down to 12.4. 12.3, and they shouldn't do that. Your battery's in tip-top shape. Well, I shouldn't say they shouldn't do that. If you have sufficient load on them, maybe they should do that. But I had all of maybe 20 watts, 40 watts max on them. So when you're drawing 40 watts max, and you're talking about 110 amp hours, plus this one 90, so 200 amp hours, when you're pulling on a 200 amp hour battery bank, and drawing about 40 watts, you do not expect the voltage to drop from 12.7 to 12.3, 12.2, whatever. It should stay 12.7 pretty much, maybe 12.6. But when you're drawing so little amperage, you shouldn't see any really downward motion in the voltage there, in the voltage reading. It should be minimal, very, very tiny. And for brand new batteries, you wouldn't see any, realistically, in my experience. So I started seeing these guys after 15 minutes of being the lights turned on in the chicken shed. I experienced them going down to 12.3, 12.2. My lead acid now was going down to 12.2, I think, by itself. I disconnected them. You're not supposed to put an AGM alongside a flooded lead acid battery. You're not generally supposed to mix batteries, but I did. They do have maybe slightly different charging characteristics, but really, I mean, they're still lead acid. One's just absorbed glass mat, so that really shouldn't, I wouldn't think, cause early demise, after 3 years. And like I say, I've not really treated them too badly. It's not like they've been taken down to zero, 100 times or even 40 times. Maybe in the 3 years, maybe they've been dropped down to zero, 10, 15, 20 times, maybe max. I really can't think of too many times when I've drained them down that far, where I've not gotten them back on the charger, gotten the solar panels beefed up or whatever to bring them back up. Now, you notice this one is charging. I did separate it from my chicken shed, and I've got it charging on my Genius, my Noco Genius. And as you can see right there, you can see the two reds and the orange, or the yellow. Yellow shows 75%. It's been on this charger for probably 3-4 days now at least, and it's not getting up to 100%. This puts out 3.4 amps, and it is set to the AGM cold. You can see the blue light there. That's the AGM setting. So it should be providing the correct voltage, but it is not accepting a charge. It is not getting 100% charged. I think this is near end of life. Whatever I've done to it apparently wasn't good, and because I would expect this one to be charging 100%, especially at only 2 years and 7 months. This costing $350. I would expect this to behave a bit better than this. Now it is -7 right now out here. That probably does play a little bit part of it. I did plug it into my 6 amp charger here, and that wasn't liking it. It was actually turning on and off because this battery basically isn't really accepting a charge. And if I let it settle, I think it was around 13 volts. If I let it settle, I'm thinking it's going to go down to 12, 12.4, 12.5, and it's not allowing itself to get topped off. So that's a problem. So let's go. I've been rambling for 6 minutes. Let's go down to the chicken shed. We'll look at the standard flooded lead acid battery and see how that's faring. I wanted to look at it now because it's a sunny day out, and because we've had snowy gray weather, I wanted to just see how the solar panels were charging the flooded lead acid. So let's get down there and we'll have a look. Alright, so first off, we can see we have 120 watts worth of panels there. They're nice and clean. It's been sunny today. Sun's right over there. Let's go have a look at the voltage. Now the voltage should be nice and high, but I can attest to the fact that the voltage is not that high at night. So let's see here. So we're bringing in 46 volts, and going into the battery is it's only accepting 0.1 amps. Let me turn the lights on and just see if that starts pulling down more amperage. It's probably because it thinks it's fully charged. So let's give it a second to refresh here. So the lights are pulling 2 amps there. You can see it under the lights. It's pulling 2 amps. And if I look at the voltage, it's pulling in basically 2 amps as well, because it's negative 0.1 amps, so it's pulling in like 1.9 amps right now, which actually is a little low. Oh, there we go. Okay, so now it's with the lights on. Oh, it went down again. It was pulling in almost 3 amps. Oh, yeah, there it was again. So it's pulling in 2.9 amps basically right now, and because it shuts itself off, it doesn't draw in power when it doesn't need to. So it thinks this guy is fully charged. This is, of course, my Nautilus 110 amp hour flooded lead acid deep cycle battery. Actually, this has 115 amp hours. I made a mistake. So this is 3 years and I forget how many months. 3 years and 4 months, something like that. So again, I wouldn't expect this to die until maybe 4 years. I would expect at least minimum 4 years out of it. And like I say, I've not really done anything real bad to this. It's sitting out. It has sat outside through -20 temperatures. But that's the life it has to live. As long as you keep it fully charged, it should be okay. Now I have checked the fluids, within the last 6 months or something. I should probably check those again, make sure the fluids are up. But I can say that it's not doing very well for voltage. Now I was waiting for a sunny day just to see if it would top off and then start acting correctly again, because when they were both connected, I think, we didn't have, there was a few days where it wasn't real sunny, so maybe they weren't able to get charged up, topped off as well. And you can see here I've only got 100, what is this, 120 watt, go upside down, 120 watt inverter here, which just, it only turns on when I flip this switch basically to turn on the LED lights in the system. The only other thing that is connected full time is this, these two guys, this timer and the temperature sensor, and those, you know, maybe take a couple of watts, but that should be absolutely insignificant for a 115 amp hour battery, not to mention the other battery which was sitting there, which would have given me 205 amp hour battery bank. So yes, I don't know what I did wrong with these, but my experience to date is that neither of these batteries are any good. I paid a premium for the pure lead AGM, which used to sit there, $350. This costs $150. So the fancy one that lasted even less time, apparently, than the flooded lead acid cost $200 more. So, what would I recommend? I would recommend the old-fashioned flooded lead acid. Amp hours for your money. This is way better. 115 amp hours for about $150 versus 90 amp hours, which was for the $350. The next step I'm probably going to do is, well, I'm going to keep using these till they're completely useless. They do still turn on my lights, and they're going to do so for many years. It's just that they go down very quickly in voltage when I turn the lights on. So whatever, I'm going to keep using them. I'm going to use them till they're completely wrecked, and because I have nothing to lose at this point. But I will try and restore them a bit with the Noco Genius charger there. I don't know if it's going to help or not. But I separated them so that one of the batteries could get full power from the 120 watt panel, and maybe do a bit of restoring on it. Like I say, I only use these for LED lights, so they're not getting used much. So they should stay 100% fully charged throughout the year. Throughout the season, basically. Here's the chickens. So anyways, that's the update on the two batteries. I've got them separated for now. I'm not happy with them so far. After 3 years, you know, I'll just round them both off to 3 years. I would have expected 100% capacity through 4 years, but and I hadn't noticed a drop in their capacity for the first 2 years, and I was always paying attention. I think it was only this last year where I started seeing a lessening of the general capacity of the batteries. So I'll have to go Google it and see if other people have experienced a similar issue with a decrease in capacity there after just a couple of years, but it doesn't look well. Again, if you're going to buy a cheap renewable resource battery, I would say go for this 115 amp hour marine RV flooded lead acid deep cycle battery. Like I say, amp hours for your money. This is the best value. What I will probably do next, and I'll probably have a whole other video about it, is I will see if I can get some lithium ion batteries, and even I don't even care if I have 200 amp hours. I don't need that much storage. Even if I could find 20 amp hour, 40 amp hour lithium ion battery, which they're getting cheaper these days with all the power tools out there that use lithium. And so if I can find one of those and use that for renewable energy, the properties of the lithium ion should be a lot better. I should be able to discharge them a lot more and recharge them a lot more times than the old lead acid stuff. So I'll probably take on to the end of this video some information about the lithium, and maybe if I can find some reviews on these guys and see what other people have seen. But for now, it looks like, you know, I don't use them that hard. It looks like you get 2 good years where you get 100% capacity, and then it's downhill from there. So like I said, I was expecting 4 years, because kind of what I find with nickel cadmium rechargeable like AA batteries and that sort of thing, you get kind of 4 good years of use. Now, I've never actually measured the decrease in capacity in those nickel cadmium batteries, but you usually seem to get full power for about 4 years, and then they decline quickly after that. not necessarily quickly, but noticeably they decline in capacity. So that may be what I'm seeing here, the decline in capacity as they age. As I forget what it's called when the lead breaks off. The name escapes me, but anyways, sulfates, when it sulfates up or whatever. So that is my 3-year review, and I'll take some stuff on the end, hopefully, if I remember. And let me know how many years you get out of these. Are you charging them regularly? Are you keeping them indoors where it's a bit warmer or less, cold temperature and all that sort of stuff, which may cause issues with them? And what's your recommendation for your solar projects and your solar applications for this? Is there something better, and is there better value for your money in terms of amp hours you get out of it? So look forward to a lithium ion battery test, and I'll see if I can get one of those and maybe use some of that in my off-grid stuff as well. So thanks for watching, guys, and stay tuned for some of the after video stuff where I kind of go through the pros and cons of lithium ion and some other reviews. Thanks for watching, guys. So I did find this interesting review of lithium ion versus lead acid, a very simple comparison here. And if you kind of put two of the same sort of amp hour batteries together, here's the kind of numbers you get out of it. So the lifespan of lead acid is about 300 cycles. So using it once a day, cycling it once a day, down to 60% or whatever. Lithium ion will cycle 5,000 times. And this, you can see the amp hours there, 110 amp hours. That's very similar to my lead acid, my flooded lead acid, versus the 100 amp hour lithium ion. Now the cost is obviously a big difference. So you can see that the plain old lead acid battery is about $340. That is equivalent basically to my AGM battery. So I guess they're talking about a sealed battery, since lithium ion is also sealed. So that makes sense. So that's a more expensive battery. And so the cost of that is about $340 for the lead acid versus $1,300 for the lithium ion. So quite a price difference there. And so the length of time that it works, the number of batteries you'd need in 11 years if you were cycling it daily. For the lead acid, you'd need about 11 of them, because you're going to wear them out in about a year for the standard lead acid. So by that standard, I guess my usage of almost 3 years, although I wasn't using it up daily, I was maybe using 3 to 5% of it daily. But they suggest that you need 11 of those over 10 years, one a year. Whereas with the lithium ion, effectively it will last for that same 10-year period by itself. So then you multiply the number of batteries you'd have to buy if you're buying this AGM every year for 10 years. And the total cost of ownership, if you have this set up and you need it to work at 100% capacity, is for the lead acid near $4,000. Whereas for the lithium ion, it's still only $1,300. So the total savings in this kind of simple comparison is about $2,400 over 10 years. So I would think, even if you look at the $150 price tag, let me do quick math and get you that number. So that actually ends up being a great comparison between my Nautilus Ultra XD AGM battery and a lithium ion. If you then compare it to my flooded lead acid Nautilus battery, which is the lower tech version, which has happened to last just as long as my AGM, it's about $150 for that same battery, which has 115 amp hours versus the 90 amp hours of the AGM. But in this case, if you consider they die after about the same amount of time, which it appears they have in my usage anyways, I'd need to replace that flooded lead acid battery about 11 times as well. So 11 times 150 is $1,650, which in the end is still greater than the amount you need to pay over the 10-year lifespan of a lithium-ion battery of $1,300. So you save about $350, even if you get the low-tech flooded lead acid battery. So you don't save a lot if you get the cheaper kind, but if you need the sealed product because it's going to be in your RV or something, then in this case, over 10 years, especially if you're using your RV a lot, you save quite a bit of money by going the lithium ion route, although obviously the output initially is far higher. So the first year you're paying, effectively 4 years up front, 5 years up front or whatever, 4 and a bit years up front in the cost of the thing versus your standard lead acid AGM, sealed non-spillable battery. So that's quite an interesting chart actually. So I'll leave that up there for a few minutes. You guys can look at that and come to your own conclusions. Lithium ion over the long period actually does save quite a bit of money. I can't afford $1,300 for 100 amp hours, but maybe if I can find 20 or 40 amp hours, maybe that is something I could buy and plug it into my off-grid chicken shed project. And I imagine I would realize the same percentage of savings over that same 10 period of time. Certainly, if these batteries only last 2 to 3 years, I don't want to put it 150 every 2 to 3 years. It's more easily done with the flooded lead acids because of its price. But I certainly wouldn't be paying $350 every 2 or 3 years to get maximum capacity out of my solar project. It just wouldn't be cost effective. So anyways, I hope you guys found that interesting, and let me know your guys' thoughts. Thanks for watching, guys, and we will see you guys in the next video.